Hello students, we are going to study linear control systems. I have already shared the syllabus, course objectives, the evaluation process of this course with you all in the Google Classroom. So let's start the topic, and if you have any doubts or queries regarding the subject or the topics that will be discussed in this lecture, then you can discuss all your doubts on the live session, or you can mail me your doubts. Okay, so let's begin. So first of all, I want to talk about why do we want to study this subject? Why do we want to study control system? What is the need of this subject or this course? So let me tell you that near about every phenomena or every engineering or non-engineering object that we see around us has got some kind of control engineering in it, which you will realize very soon. And in that sense, we can say that control engineering is not specific to our branch. It is mainly it caters to mainly all disciplines of engineering in some way or the other. Okay, so it's there in communication engineering, mechanical engineering, robotics, electronics, aeronautics, automation, and instrumentation, industrial engineering, and of course our electrical engineering. So it's basically a multidisciplinary subject with its applications almost everywhere. You will find its applications almost everywhere. So here I have framed some questions, and this will give you a vague idea of what are we trying to go into. Okay, so first of all, have you ever wondered what if there were no on-off switch provided for fans, lights, appliances, etc.? Okay, so that would mean that, like, if a fan is in the on state and you don't have the switch, so you just can't turn it off. So you don't have any choice over there but to bear with the fan. Or in other case, if the fan is off and you don't have any device to turn the fan on, in that case again you don't have choice. So you again have to bear that situation. So what exactly is this on off switch or simply a switch doing in this? You can realize very easily that this switch is basically giving you a control over turning on or turning off over any appliance for that matter. Thus, this switch becomes a control system, and this control system is designed in such a way that if you want any appliance to turn on, then this switch it allows the current to flow, and if you want that these appliances should turn on, then it cuts off the supply. This is the role of the switch. So in that way, this switch is acting like a control system. Similarly, what if there were no remote controllers or any kind of controllers for televisions or air conditioners? Again, the same thing. If you want to suppose uh, uh, raise up the volume of your television, or you want to change the temperature of your room using and you have an air conditioner over there, so what do? Generally you use the remote controller, and if you want to turn up the volume, then you just use it. If you want to turn down the volume, you'll use it. If you want to increase the temperature, then you will just give some input, and accordingly your air conditioner will work in such a way. So here, what this remote controller and this television set or this air conditioner, what are we talking about, or what is going on over here? With the aid of this remote controller, we are able to change various. We can change like we are able to change. We have having we can vary various applications. Okay, for instance, even if you like have a mixer grinder and you want to change the speed of the grinder, in that case you have a knob along with it, and that knob it's used to control the speed of the grinder. So that knob along with the complete system inside the grinder, it is acting like a control system, because it is giving you a choice over that appliance. You are getting a choice that you can, okay, you can change the speed. Similarly, in case of air conditioner, you have the choice to change the temperature. In case of television, you have the choice to change the volume, to change the channels, and so on. Next, how is the speed of the car controlled? Here again, you might know the answer, but right now what I want you to think is, what if there was only one speed with which the car could move and no variations were possible? Suppose it simply had a motor with a constant speed and the car would run at only that speed. What then? So then you'll realize that no, inside this car there is some system which is enabling you to change the speed. So there is some control system. Because why are we saying it as control system? Because there is some system which is allowing you to control the speed, not just any speed. It's allowing you to control some particular speed according to your choice and your will. That's why we are saying it as a control system. Next, how are we able to launch satellites and we are able to monitor them? Now, is an example of a terribly complex control system, that is the launching of the satellites. And it's such an incredible work done by our scientists and engineers that they are able to launch the satellites, they are able to monitor them, place them in their defined orbits, and receive the data and so on. So again, a lot of controlling, there is some system and a lot of controlling action according to our choice is done in order to perform various functions. Thus, a very complex but a system is designed over there, and that system will be known as a control system. How is it possible that the missile hits the target located at a large distance with almost 100% accuracy? So, with all these examples, you will understand that these, starting from this very simple example, that is a switch, to more complex examples like launching of satellites and using missiles, you will understand that there are various systems involved, and systems are made in such a way that you can control that system according to your wish and will. Hence, we call the engineering that is involved in this will be known as your control engineering. And you can see that so much of variety is there. It's not just specific to one particular application. Indeed, in every application, you'll find that if you are making something in engineering, for instance, if you are designing something, there must be some control system available to it. We'll see how. So here I have enlisted various examples, and these examples have been taken from our daily lives. Okay, and you have seen all these examples around you, and now you have to think in terms of control engineering. How this, there is some appliance, and what are the control engineering aspects associated with those appliances. Like for instance, we have fan. Fan everyone one has seen, and in the previous slide also I told you that one of the control aspect of fan is that how are we able to control a fan which is there in a room. So what all functions can you perform using it? First of all, one choice you have that you can turn on a fan or turn off the fan, and for that instance it's common to almost all the examples that has been listed. Second, controlling is also there, that you can also vary the speed of the fan using a regulator. So one more system has to be employed over there. If you want to vary the speed of the fan, then you have to have an additional system, An additional system will allow you to control the speed of the fan, and if that additional system is not present, in that case your fan will run at only one speed. So that additional system will be the control system of the fan, which is allowing you to change the speed. Similarly for light, as I already told you, on off facility is there for almost all of the examples. Nowadays we are having lights which uh, we have those lights which you can vary the color of the light, or you can dim the light, and so many other functions are there nowadays. So that is the additional control that is being given to us nowadays. Air conditioners, air conditioner definitely a control system, a bit complex control system in comparison to fan and light. But here also again, how can you control, and what can you control in this air conditioner? You can control the temperature of the room. You have to give the command to this air conditioner. Thus there must be some sensors over there, like if you are having a remote controller, then you will give the command, and that command has to be sensed by this air conditioner, and according to your command and whatever is the outside temperature, the compressor will turn on, and it will adjust the system in such a way that you get the desired result out of it. So again, a control system is there because you are able to control the temperature of the room, and that system is present inside this air conditioner. Electric iron, everyone must have seen. So in that electric iron, again you have the controlling aspect in many of them. How? Because there are variety of clothes that you have to iron, and for different variety of cloth it requires different temperature. Okay, and like there are so many options available in your electric iron. There are options like cotton, linen, silk, wool, rayon, nylon, and so on. So according to the fabric, you can change the temperature, and accordingly the temperature of the of electric iron will change. Thus you are having the control over the temperature. It's based a very simple, though it's based on bimetallic strip, and it's very easy to operate also. So that is the controlling aspect in electric iron. Washing machines, again you have so many options. You can change the speed of the washing machine. There's this slow wash, normal wash, then high speed. You have the option of rinse. You have so many other options in washing machine, and hence there for having these many options, there must be some control system inside the washing machine, which is helping you to have these choices. Mixer grinder, similar to fan, you can change the speed of the mixer grinder, and that gives you the control over the speed. Computer system, you have to give so many commands, and accordingly you want the results. So there must be some control system inside this, which is helping you to have to have those choices. So, in all, what I want to say, like in every example, you'll see that there must be some choice, and if there is any choice, then there is some kind of control system involved. Okay, so here you can see that we have we can classify these examples in as fairly simple control systems like fan and lights. Then we have a bit complex control systems like robots, because controlling of robots, the system that will be made in order to have a robot, it will require a tedious uh, uh, brainstorming, and you have to do a bit more of thinking. That's why this will be termed as complex control system. And then, yes, human body. I'll say that human body is the utmost complex and sophisticated control system. Why I'm saying that? Because like right now you can see I'm watching the screen, my brain is processing the content and then delivering the lecture, and all this is happening at such a high speed. And at the same time, my brain is sending the signal uh, to command to move the cursor. So my hand is responding. So amazing, isn't it? That's why I say that human body is a perfect example of a control system. So after discussing all these examples and where all you can find it, the question comes like, what exactly is a control system? So I would say that if you have a choice in any situation, then that can be called as a control situation. And then a system is a set of things which is working together to perform some mechanism. So if you have a control over the system, that system will be known as a control system. Now we can discuss control system in terms of more in terms of block diagram. Let's learn it through this block diagram. Here has I've regarded this control system as black box. Why I'm saying it as black box? Because as you have seen that there are variety of applications, and for all those variety of applications, the how to design this control system, it will vary. It will vary so much. So that's why I'm considering it as a very general, and I'm saying that it's a black box. But in general, for any control system, you'll say that there must be some input. That input, I'll call it as my desired response. Okay, and then we'll have some output, and this output we'll call it as actual response. Okay, so let's understand this with the help of an example. I've written that there is some one control situation. The control situation is what? Very simple. To change the temperature of the room by using air conditioner. Okay. So, like for example, here input, you have to change the temperature of the room. So here your input or the desired response is the temperature setting through remote controller or manually. Like for example, I want the room temperature to be maintained at suppose 26 degrees centigrade. I want my room temperature to be 26 degrees centigrade. Okay. I set this 26 degrees centigrade through a remote or through manually through the knob if that is being provided. Now this control system over here, what will it do? The control system here is in my air conditioner. It will sense this data. It will sense this 26 degrees centigrade. And this I am saying it as black box. It will sense the output and it will sense this input, sorry, and it will give some output. Now when I set the temperature at 26 degrees centigrade, suppose outside temperature was 30 degrees centigrade. Okay. Suppose the outside temperature was 30 degrees centigrade. Then my control system, this should sense the input and it should turn on the compressor, and then it should work in such a way that the outside temperature, it drops down from 30 degrees centigrade and it becomes equal to this 26 degrees centigrade. Then I will say that my control system is working properly. So input that I had fed was in accordance to what I wanted. मुझे क्या चाहिए था, this was my desired response, क्या चाहिए था, and the output that I am getting from the control system is my actual response. Okay, so the desired response is that the room temperature should drop down to 26 degrees centigrade from this initial 30 degrees centigrade. But it might happen that if my control system is having some problem with the accuracy, or some there is some fault, or no system is 100% accurate, then my actual response may not be actually 26 degree, but somewhat like 26.5 degree or so. Okay, it can be some, not exactly 26 degree. So that's why I say that my input and my output, input is the desired response and output is my actual response. And my control system should act in accordance. An air conditioner, a control system for an, I'm talking about the air conditioner system. This was my control situation. So for my control system in the air conditioner should be able to vary this temperature and maintain it in accordance with what I desired for. Suppose I had given this input and the output would had remained equal to 30 degrees centigrade. In that case, I would have said that my air conditioner is not working and I have lost control over my air conditioner. Okay. So this is the simple concept of your control system. For any control system, you will find that there will be some desired response and then there will be some actual response. Similar to this one, like in case of fan, if you want to change the speed of the fan, okay, so what you'll do, desired response, you want to speed it up, then you'll rotate the regulator knob. Okay, so that increase of the speed will be my desired response. My actual response, sometimes it happens that you just rotate the regulator and it's not working and the speed remains the same. So that will be my actual response. And in that case, I'll say that my control system is not working properly. Or the other way, when I change the regulator, when I turn the knob, then the speed actually increases, then I'll say that yes, my control system is working properly. Okay, so everywhere there will be some desired response and there will be some actual response. This is the simple concept of control systems. I hope you would have understood a little bit about it. And then control system with subsystems. Now, in the previous example, like I told you that there is an air conditioner and I want to change the temperature, and there was one system involved in it. But in there may be many situations where you don't require just one control unit. Instead, you require several control units, and you have a very uh, bigger set. Okay, you like in case of like you have steel plants. You must have seen any steel plant, or in case any other plant where you'll see that you have to manufacture something. Okay, in any factory you have to manufacture something, so there are various processes in that manufacturing plant, and every process requires some kind of controlling in it. So that way we can say that the complete manufacturing unit will be can be divided into various small systems doing individual jobs, but the output of one system is given as the input of the other. It might happen like that, and you can have many small systems, so these systems will be known as subsystems. So there can be a control system having many subsystems. Okay, and then we can always have a system which is known as a feedback system. Now this concept you might have learned in your other subjects like analog electronics also. So you might be aware of it. It's a very simple concept, feedback concept. Feedback is nothing but you take a part of the output and you compare it with some input. You compare it and that error is then processed forward. That is the concept of feedback system. Suppose I'll again explain it with the example of air conditioner like this one. In air conditioner, I have a same thing. I wanted 26 degrees centigrade as my uh, desired response, and the output actually initially it was 30 degrees centigrade because outside temperature was 30 degrees centigrade. Now if I apply some kind of feedback over here, okay, if I apply some kind of feedback over here, what I'll do, I'll have a sensor at the output. Okay, I'll have the sensor at the output. I'll check that what is the output that I'm getting. So the output that I'm getting is 30 degrees centigrade. I take this 30 degrees centigrade and I take this reference level 26 degrees centigrade, and I compare these two values. Okay, when I compare these two values, I find that 26 degrees centigrade minus 30 degrees centigrade. Okay, so oh no, there is an error of 4 degrees centigrade. If there is an error of 4 degrees centigrade, then that error will be provided to this control system, and it will basically trigger something. I'll say in very uh, layman's language that it will trigger the compressor, and it will ask the compressor to turn on and work in such a way that this error should reduce. So maybe a minute later this temperature it reduces to 29 degrees centigrade. From 30 degrees centigrade it reduces and becomes 29 degrees centigrade. Okay, if it becomes 29 degrees centigrade, then the error will reduce to 3. Again, there is a difference, so it will trigger the compressor. Okay, then error might reduce to 2, then error might reduce to 1, and then finally there will be no error. When there is no error, in that case, it might say that yes, now the compressor should not work, and the outside temperature has become equal to your desired response, and this might actually turn off the compressor. But once it turns it off, and again it might happen that the temperature will start rising, the outside temperature might again start rising. If it again starts rising at it had reached 26 degrees centigrade, it starts rising, it becomes 27 degrees centigrade, then again there becomes a error of 1. So that error will again trigger the compressor, and it will work in such a loop manner. So whenever you see that there is some kind of loop involved, your output is actually being compared with the input, then you say that the system is having a feedback. So a system that maintains a prescribed relationship between the output and reference input by comparing them and using the difference as the means of control is known as your feedback control system. And like the example of manufacturing plant I told you, in a manufacturing plant you might have various small systems, like there is collection of raw material. Okay, that raw material has to be processed. So कितना process कैसे करना है, कितना whatever the raw material is, you might have to grind it to smaller grains, and then that grains has to be given to another system. Then again some chemical is suppose mixed with it and you get some other output, then that output has to be again fed to some other system, and finally through various stages the input of one is given to output the output of one is given as the input to the other, and you have various stages at the end of which you are getting some output. And in that case you say that there is a control system having various small control system, so it has various subsystems. Now uh, here I have taken you have to this is like some kind of short case study. Compare the two control situations. Okay, so I've given one situation is that there is a farm where some X crop is grown. Like you have the crop of rice and rice is grown, and then there is a condition. The condition is that this crop requires water for a particular moisture level in the soil, say Y. So you can say that okay, Y amount of water is needed for the soil in order for the crop to grow. Okay, now you have two cases over here. First case is a pump is employed and it delivers water for a fixed amount of period which is set as per the moisture level Y, moisture level condition Y. Okay, and the second case is pump is employed with sensors in the soil which when sense the moisture level as Y give the signal to stop the pump. Okay, so you can see that case A and case B, the situation is same and you have your result has to be same. The result has to be that for this X crop you want Y moisture level. But to achieve this we are going through two methods. First method, pump employed, water is water has to be delivered for fixed time period, and second case, sensors are there in the soil which sense the moisture level and give signal to stop the pump. Okay, so here I have given the two systems. I have shown them the use of your block diagram. So in case A, what are we doing? We have one pump system. What I am doing, I'm basically turning on the pump for some fixed time period, and my output is that my pump will deliver water up to level Y. Very simple. Second system, with the help of block diagram, what we are doing, we are again having pump system. Okay, but we are not delivering for a fixed amount of time. We have not fixed any time period for this pump. Instead, what we are saying that we are turning this pump on and we have some sensors provided in the soil, and those sensors will sense the level of the moisture. So this I am just for the sake of enumeration I have given, like there is some level where moisture level has to be sensed, and those sensors when they sense it, and if it becomes equal to Y, in that case that sensors will give the command for the pump system to stop. In both the cases you see that ultimately the water level will be equal to Y only. Okay, so what is the difference between these two cases? You have to compare it. You have to compare case A and case B. Okay, so you'll easily understand very few things, very basic thing. In case A, you will find it as pretty simple. If you were an engineer, then you'll find that this is pretty simple because you have to do nothing. Have to just turn on the pump for some fixed period, and that is ensuring that Y level of moisture level is attained. Okay, and it is cheap also. Why cheap? in comparison to this, because there is no extra sensors actuator system in this case. So it is having less number of elements also in it. Okay. If this system is working fine, then why will we go for the other system, that is case B? This is complicated because it has sensors and actuators. It is costly due to involvement of additional elements. So I'll say that case A, although it's simple, but in case, what if we keep the pump on for 10 minutes, but what if this, for some reason, a fault happens in this pump, and you have made it this automated system, no person is in charge of this, no one is uh, dealing with it, means directly, no human intervention is there, and this pump starts only for fixed amount of time and then turns off, then stops after fixed time. So in that case, what if this pump, if suppose it fails, then how are you going to analyze that? How are you going to analyze that? No, the moisture level Y has not been achieved. Who is there to tell you that the pump is not working? Who is going to tell you that the output level is not actually Y but it's instead 0? What if the system undergoes any fault? Or what if the system gets corrupted? Okay, if what if the system is delivering Z water level instead of Y, and who is there to check it? Okay, so here you can see there is no relation between input and output. If there is no relation between input and output, then I can easily say that this system is your open loop system. Although a very simple system works perfectly if the system is perfect, but if there is some corruption or if there is some fault in the system, if your output is not coming in accordance to what you had designed it for, then you don't have any means to check for the error, or you don't have any means to check for the accuracy of the system. While in the other case, in case B, if this pump it doesn't work, if this pump system doesn't work, then what will happen? If it doesn't work, then it will be sensed by this feedback loop, and the output is continuously monitored over here. This is where you can easily understand this is a closed loop system, and this is where this your closed loop system has advantages. Okay, this case study was given only to tell you what are the advantages and disadvantages, or how can you differentiate an open loop system with closed loop system. Open loop system, there is input, there is control system, there is output, but you are not comparing your output with the input, so that becomes your open loop system. In closed loop system, you are comparing the output and checking it with the desired input. Okay, your actual response and your desired response is actually being checked, and that gives you a control over the accuracy, or if there is some fault in the system, then it gives you control over that also. But yes, the disadvantage for this system will be that it will be a bit complex and it will be a bit costly. Having discussed all this, we can now discuss closed loop and or the feedback system with open loop or no feedback system. So in closed loop system, easily you can say it has feedback being used. Open loop systems, there is no feedback at all. In closed loop systems, there is actuating error. In case of air conditioner example I told you, actuating error is nothing but the difference between the input and the feedback signal, and it is used for the desired output. There I was saying that the output temperature was 30 degrees centigrade, my input was 26 degree, so I was checking the difference. So that difference was becoming my actuating error. Okay, for 4 degrees centigrade was my actuating error, and that error was used to trigger the compressor. In our open loop system, output has absolutely no effect on the control action. Whatever is the output, we have to accept it. Feedback causes system to become relatively insensitive to external disturbances and internal variations. In this case, the pump case only, you can understand it very well. If there is some disturbance in the system, if the system is not working properly, then your output will definitely get affected. But as this output is being compared with the input, and that error, if you are getting some error, then that is going to affect this pump system. So it's a kind of loop system. If you have error there, then it's going to be fed over here in order to reduce the error. Hence, if you have some external disturbance or internal variations in the system for whatever reason, your feedback system will be fairly relatively insensitive to it. Okay, it won't affect the operation of your system. Whereas in open loop system is sensitive to parameter variations. Here, if there is some you have made the pump system, and pump system will have many components in it. Okay, like suppose it has some kind of you are electrical, you belong to electrical engineering stream, so you can very easily understand that there will be some components like resistive components will be there, and other components will be there, which might change with the time. With the temperature, the variation will be there in various components. Okay, so like with time and with the change in temperature, your pump system, it is what it was designed for, it is not working properly. And here in this example, I told that pump is on for 10 minutes and it will deliver the water level up to Y. But if this pump system is not working, then with time and variations, it might happen that internal system is varying, and hence your output is getting affected due to it. But here you don't have anything, you don't have any measures to mitigate this, to reduce this problem. That's why we say that in open loop systems, it is sensitive to parameter variations. Next point, these systems are complicated systems with high stability concern. Very important point. These are complicated systems with high stability concerns. And these are simple systems with low stability concerns. Okay, it's a very important point. We will discuss this later in very detail, but one major misconception which we generally have is that we use closed loop systems. We are using closed loop systems to make the system stable. But the fact is that the feedback that we are using, it might actually make the system more unstable. In many interviews, they ask this question that why do we use feedback? And most of the students answer that it's used to increase the stability of the system. But in fact, it happens that it might actually reduce the stability of the system. Okay. Stability is not the criteria to use closed loop system. Closed loop system should be used where system is affected or is vulnerable to your external disturbances. Okay, these are relatively insensitive to external disturbances and internal variations. So those conditions where you have a large number of external disturbances due to which your system might get affected and output might actually vary a lot. In those cases, you should definitely go for closed loop systems. There may be systems which are pretty secured and they don't have wide variety of parameter variations. There you don't need to have the closed loop system. There you can always go for open loop systems. So the last point, it concerns with this only. It should be employed in systems which can have unpredictable disturbances or variations, and open loop systems should be employed in situations with known inputs and no disturbances. For example, your traffic light control system, your washing machine, these are the examples of open loop system. Closed loop systems, your temperature control systems, human body is a closed loop system. Okay. So here I have given a generic open loop system, the block diagram of a generic open loop system. Okay, for any open loop system, it can start with some input or the reference, and we have various subsystems over here. We have got three subsystems, you can say it like that. First subsystem is your input transducer. So your input actually can have some different property. Okay. This input transducer, it can convert this input into in the form which can be used by the controller. Like if you have any system and your input is suppose some audio signal. Okay, then that audio signal, this input transducer, what it will do, it will convert that audio signal into some electrical signal. An electrical signal, because your controller can understand electric signals, but it cannot understand your audio signal. So in that way, you can have any kind of input, and that input transducer, it can convert it in the form that can be used for this controller. Okay, now this controller will drive the process or the plant. Okay, process or the plant, and we can have we have shown over here that there might be disturbance at this point. It's not compulsory that only at this point. Disturbances can be there at any point, at any level there can be disturbances. Okay, and your open loop system cannot compensate for these disturbances. That is one of the major drawback of your open loop system. Your open loop system will actually add these disturbances. Okay, and if you have noise, then that will be added, and that will be added and given as the output. Okay, closed loop system, your generic closed loop system. The disadvantage of open loop system was what? That you have no compensation towards the sensitivity or the disturbance, and hence you are unable to correct that. Here, similar to this previous block diagram, we have an added feedback level over here. Other things are same. You have input transducer, you have controller uh, which drives this process or plant. You have disturbances over here, but you have one added feature, that is this output transducer of the sensor. Okay. By the way, transducer means a device that converts any physical quantity like your temperature, pressure, sound, brightness into electrical signals, and vice versa. So here the output transducer, here we have taken this output transducer, it takes the output and it converts into a form again suitable for the controller, and this system can actually compensate for disturbances. Thus, they have greater accuracy than your open loop systems. They are less sensitive to noise disturbances. Okay, so now you can easily differentiate, I think, between your open loop systems and closed loop systems. Okay, so with all this knowledge about control system, I will end this today. There is a little home assignment that I have given. Okay, for you all, you need to think about any control situation and make the block diagram for it. Identify whether it is an open loop system or a closed loop system, and you simply do it in a piece of paper and send the scanned copy to me to the link which I will provide shortly to you. Okay, so thank you very much to this home assignment.